we're looking at Chapter 2, Number 4 homework. You can find the solutions for that on the website, but let's just try it here. So first of all, I'm going to write down everything that I know. I know that x is equal to 40 and t is equal to 8.50. I also know that this object is moving, and he has an initial speed that I don't know, and then he has a final speed equal to 2.8 meters per second, and I don't know his original speed, and I don't know his acceleration, and those are both things that I want to know, his original speed and his acceleration. So just like we did in class, and I think you should do this too on the exam, when you get it, write down the two equations that you have. That is that x is equal to v naught t plus 1/2 at squared. I like to write them right next to one another. And then also v is equal to v naught plus at. And I'm going to underline the things that I don't know. I don't know v naught, and I don't know a. I don't know v naught, and I don't know a. I can go through and then put in numbers if I like. 40 is equal to 8.5t plus 1/2 at squared. And I'm going to do that over here too. 2.8 equals v naught, which I don't know, plus 8.5a. That's where t is 8.5. So I've just rewritten them with the things that I know and the things that I don't know. So I can... Oh, I did this wrong over here, didn't I? Sorry about that. So this should be 8.5 v naught. You'll see what I did there. I switched the order of them because we usually have the coefficient in front of the variable. I think that's all right. Does that all look okay to you? Yeah? All right, so now I want to notice that I have two unknowns in each equation, but they're the same unknown. So since I have two equations and two unknowns, that is a system that I can solve. You can do this in a variety of ways. I want to do it this way, where I say, let's solve this for... Oh, wait, no, I'm sorry. I messed up again. I know here t squared. So I'm going to put it in here, 8.5 squared. All right, so I know what v naught, I don't know what v naught and a are. I'm going to solve this for, let's solve it for a. I'm going to say that a is equal to 2.8. Actually, no, I'm not going to solve for a. This one is a little more complicated than the ones that you have. I'm going to solve it for v naught. Yeah, let's solve for v naught. Is equal to 2.8 minus 8.5a. And I'm going to take this, and I'm going to plug it into over here for v naught. And then I have 40 equals 8.5 times 2.8 minus 8.5a plus 1/2 a 8.5 squared. Now that's an equation that I can solve. I'm not going to do it here, but it should be an equation that you can solve for this. So you just simply solve for a, and then a, whatever it is, I can take that value and then plug it back in up here to get a value for v naught. Okay? I'll give you easier numbers. This one was made difficult just because the numbers were difficult to work with. But like we did in the fall 19 exam, I don't know if you remember doing that one in class, the numbers worked out a lot easier. So it was just sort of easier working with this. But the process is still the same. That I have two equations with two unknowns. I solve one of the equations. Usually that's going to be this equation because it's just a simpler equation. It doesn't have that square in it. I solve one of the equations for one of the unknowns, and then I substitute that back into the original equation. Yeah, Caleb?
So what I did, I solved for a in the first equation, but I did it with the variable equation,
Yeah, so you got A equal 2.8 minus V naught.
Well, we did it with the variable expression first, so I did like the final minus the initial over T with the equals V.
Okay.
You know, V equals V naught plus AT.
Oh, yeah, yeah, yeah.
There,
Mm-hmm.
and that's the A expression. And I just added that, like I.
Yeah, you can do that. Yeah, that's a great way to do it. So he said that A is equal to V minus V naught divided by T, right? Isn't that right? And then you took this and you substituted it up here in for A. Isn't that?
There's just one step out there.
Yeah, yeah, that's a great way to do it, Caleb. In fact, I like that better. You hold off on putting the numbers in. That's effectively what you're doing, is you're holding off on putting the numbers in. In doing it that way, most students have trouble doing it that way. It's just they like to work with numbers better than letters, that the letters just swim around inside their head. But in doing it that way, you can spot mistakes more easily as you move through the problem. That's a really good practice if you do it that way. Okay, I know that seems like a jumble, but with practice, you'll find that solving that system of two equations is not that difficult, really. That it's something really that everybody should get correct on the exam. Okay? Are there particular questions that y'all want to look at? Do you want to focus on Chapter 1 or Chapter 2? Or do you want to preview the stuff that we're going to do on Monday on vectors that will also be on that exam?
Can you explain, like, how does a line become, like, the difference between speed and velocity?
Okay, sure. Yeah, so,
It's a fairly new concept, and I'm really having trouble grasping.
yeah, sure. So, speed is the magnitude of velocity. Now, so far we've only been working in one dimension, and so when we give the velocity, we say that it's plus or minus, let's say that it's minus 3 meters per second. And so in this case, this is the direction, and this is the magnitude. Now later when we get into vectors in 2 dimensions, then we might say that the speed, or the velocity, is 3 meters per second at 20 degrees from the x-axis. We'll see this next week on Monday, and this, you'll need to know this for your exam too. And in this case, this is my magnitude, and this is my direction. So the speed is simply the magnitude of the velocity. Whatever the speed is, that's going to be the velocity. Now, it's just the numerical value. Now, probably what's confusing you about it is that when we deal with, say, a plot like this, y versus t, and then I say, well, the speed is given by the slope of this line. Actually, the velocity is given by the slope of that line, and the speed is decreasing. I would say that the speed is decreasing. In fact, the velocity is decreasing too, but it's slowing down, that the speed is going down. But if I have another situation, see, because it's fast here and slow here. Let me think of another where that's not true. Y versus t. Yeah, let's look at this. So here, the speed starts out big, it's fast right here, and it's slow down here. In fact, if I plot the y versus t graph in the velocity, so I'm going to take this graph that I just did, the one in the middle, and I'm going to graph the velocity versus time. I'll let you think about that for about 10 seconds. What does that graph look like? Well, I want to think about, is this positive or negative slope? And is it a big or small slope? It's negative slope. That means the velocity is negative. And it's a big slope. That means that the velocity is big. And a big negative number would be right here on this graph. And then right here, it approaches 0. It gets closer to 0. So the v versus t graph for this would look like that. That is a skill that you'll need to know. Now, here, the speed is decreasing. But notice that that statement is not technically true for the velocity. Don't get bogged down in this, but if I look at the velocity, say the velocity has a value of negative 5 meters per second here, and here it has a value of negative 1 meters per second. Numerically, -1 is bigger than -5. Okay? But when we talk about velocity, we don't talk about it in that way. We talk about, is it speeding up or slowing down? And is it in the positive or negative direction? So that's probably why you're confused, because of these graphs. Because we talk about velocity, the speed increasing or decreasing, but we don't say the same thing about velocity. We don't say that the velocity is increasing or decreasing. Okay? So speed is the magnitude of the velocity. And I think that it's not just the definition like I expect. I think you know that, right? It's the graphs and applying the graphs. We can look at some sample problems like those. You want to take a look at some of those? Because you're going to have 3 to 5 questions. Oh, no, more than that. 8 to 9 questions that are related to graphs in one way or another. And let's see here. This, by the way, is the Fall 20. I don't know if we've done the graphs for this. Yeah, let's look at this number 19. Consider this position versus time graph for an object's motion. Which of these statements is true? By the way, you're going to have a question like this where I give you a graph and then I have a number of statements and you have to assess each statement and tell me if it's true or not. So here, I start with each one. The object is increasing its speed between B and C. So here, at point B, I know that the speed is 0. I know it's 0 because the slope of this position versus time graph is 0. And here, the velocity is not 0. It has it's sped up. So it is increasing its speed. Check. That one is correct. The object has a positive velocity at E at this point. Is that true? Does it have a positive velocity right there? No. Because this is a position versus time graph, the slope is the velocity. It has a negative slope, so that statement is not true. The object is at rest at C and D. At D, it is at rest because the slope is 0, but at C, it's not at rest. It has a positive velocity. So that statement is wrong. This one's difficult. Between C and D, the object has a negative acceleration. First thing you want to ask yourself is, what is the sign of the velocity? Is it positive or negative between point C and D? Very good. It has a positive velocity. And is it speeding up or slowing down between point C and D? Very good. So it's slowing down. Since it's slowing, the acceleration has a sign opposite the velocity. That means the acceleration is negative.
Can you explain how it's slowing down?
Absolutely. So that statement is correct. Because right here, I have a big speed, and here I have a speed equal to 0. So that means it went from a big speed to 0, so it is slowing down between those 2 points. This is could be one of the hardest parts. I know the system of 2 equations is difficult for many of you, for probably most of you actually. But the graphs, because you haven't never really thought about motion in a graphical way, this could be the hardest part of the exam, interpreting these graphs. Fortunately, there's lots of practice for you. I don't see other good ones here. Let's look at actually, it doesn't look like I had many graphs on this one, but you will have a lot of graphs on your exam. So let's, oh no, here we go. Here's some more. Consider this velocity versus time graph. Which of the following best represent the position versus time graph? So remember, a position versus time graph, the slope gives the velocity. So whatever this value is here should be related to the slope. So here I should have a big negative slope on my position versus time graph. Well, which one of these starts with a big negative slope? Which one? Oh, you're right. It does start with a big negative slope. That's very good. Right? Look, this one starts with a small positive slope, small negative slope, big positive slope. So all of these are wrong. It has to be B. And it should end with a small negative slope, which it does. It ends with a small negative slope. We've done these quantitative things here. You'll have a similar number on your exam. let's do one or two others. By the way, this is a good indicator, this 25 through 28, a good indicator of what you'll have for the vectors. So if you're studying this weekend, you can go ahead and start looking at questions like these. The past few years, I've been pretty consistent in getting vectors, the first part of chapter 3, into the exam. And by the way, if you're looking at the online lectures, if you want to get ahead into chapter 3, you can look at these first 4 right here. Chapters 3, 1 through 4. Each of these, they're not that long, but we're going to do graphical addition of vectors and numerical addition of vectors. It's also the lab for next week, which is good because our exam isn't until the following week, so you'll get some extra practice in lab. Okay, let's do a few more. I think this is an important and difficult part. There was an article in the Physics Teacher, which is like a trade journal for college physics professors, and they were talking about the importance of dimensional analysis, that it really helps students in physics to begin to think about variables and how they're related to one another. We can go back and look at that if you like. Looks like we did some of these. Let's look at number 17. We haven't done that one. What is the sign of the acceleration? Remember, there are two things that are important. Is it speeding up or slowing down? And what is the sign of the velocity? What is the sign of the velocity for number 17? It has a positive slope, right? So it has a positive velocity. And is it speeding up or slowing down? Very good. So what is, That's right. It's negative. So there's a negative acceleration.
What's the case in which the sign of the velocity matches the sign of the acceleration?
Well, let's take a look. So let's do where the velocity, the sign equals.
Yeah.
Okay, hold on. Let me think.
I want to say you said it was when the object was going in a certain direction. I don't know.
Yeah, I think this one works. So if this is x versus t. Yeah. Yeah, this is right. So here I have a small slope and then a big slope, so it's speeding up. If it's speeding up, if it's speeding up, that means the acceleration and velocity are in the same direction. See how it's speeding up? The slope is initially small, then the slope gets big, steeper. And the velocity is negative. That means that I have a negative acceleration. We don't try to memorize the scenarios. I mean, I guess there are probably 4 different scenarios, but I think if you try to memorize the accelerations for those 4 different scenarios, it's just gonna confuse you. Like, use those simple rules.
So why is the chart sloping downwards if it's speeding up?
Because is the sign positive or negative as to whether or not it's speeding up or slowing down? Is the steepness of the slope. So here I have a slope equal to 0, and here my slope is a big value. It's a big negative value, but it's a big value. It's a steep slope.
So when we're looking at speed, we're looking at the slope of the line.
Exactly right. Yeah. And the velocity comes into account if it's a positive or negative slope. But the speed, you're absolutely right. It's only the steepness of the line. Okay? Good. That's good stuff. We've done these.
You would say these answers similar to your old ones, just not the same exact questions.
Absolutely. So probably for the last 10 years, I followed a pretty strict regimen as to the number of questions that I give in each topic, and every question assesses the same ideas. So if you can go back, if you can work through the exams and do well on them without any help, then you should be fine on my exam. In fact, I always tell students that after your study, like reserve an exam and go back that you haven't seen before, and then go and work it and see how you do. And if you make an A on it, you're probably okay. Go to bed, get a good night's sleep. Okay? But the questions are always new. So I always write new questions for every exam. Okay? New but similar. All right, let's do this one. You're going to have, gosh, 3 or 4 questions that are quantitative graphing questions like this. I have a motion, a graph. Whenever you see a graph, make sure you check to make sure what's on the axes. This is velocity versus time graph. So I know the slope is the acceleration. The area is the distance traveled. So what is the object's acceleration at t equal 1 meter per, at t equal 1 second? That's right here. I want to know then what is the slope of this line. And that'll give me my acceleration. Be really careful that you don't count the squares. If you count the squares, you would get a slope of 3 over 4, and you would choose A as the right answer, but that's not the right answer. Instead, look at the axes. This has a rise of 3. It has a run of 2. 3 over 2 is 1.5. I just found the slope of that line. And then I also want to know what distance does the object travel between 0 and 4 seconds. So between here and here. And to find that, I take the area under the graph. I always like to ask myself, what is the distance given by one square? So if I think about this square right here, the area of that square is 1 times 0.5. I got 1, but from 3 to 4 is 1. 0.5 is 4.5 to 5. And so the area of that square is equivalent to 0.5 meters. Right? The area is the distance. So then I can just go and count the squares. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 so far. And then I start to combine squares. Like I might combine these 2 squares. See how they add up equal to 1 square. And then I might combine, I don't know, these 2 squares. So that's 2 additional ones that I have. Or maybe, I don't know, that other one. I'll combine these 2. And we're just estimating. So we'll combine those 2. So those are what? 4 additional squares. So plus 4, that gives me a total of 20 squares. And 20 times 0.5 is 10 meters-ish. So the closest, oh, shoot, no. So I can get rid of that. I'm going to do this a little more. Oh, yes, I was only supposed to go to 4. So the answer must be 9B. See my mistake? I counted these squares, and those aren't supposed to be in there. Another great way to do this is to actually, calculate the area of the shapes. That's a more accurate way. So the area of that shape is 3 times 2, or 6. I measured this distance and this distance to get 3 times 2. And then this one is 1/2 base times height. I already have the base times height, so 1/2 of 3 times 2. That's equal to 3. 6 plus 3 is equal to 9. You see how I did that? I'm integrating. That's what integration is you're taking the area under a function. So if you go into the end of calculus 1, you'll get into integration. You're just taking the area under a function. That's all you're doing. So we just did an integral, but by hand. Whew, okay. So we've done a lot of these in class, so. Any particular things you'll want to look at, estimations or things from chapter 1, since it's been a while since we've done that? Chapter 1 stuff? Did you get it?
Yeah.
Yes.
Calculating, just like when we're the first question, it's like where you have to random it.
The estimations? Yeah.
Yes.
Look, you're going to have two estimation problems. You see how I have 2 here? You're going to have 2 as well on your exam. But they pretty much follow the same formula or the same format. So usually I'll either give you a picture of the object on your exam, or I'll give you an object that's really familiar to you. I might ask you the length of something. I might ask you the area of the something. You have to be careful that you watch the units. So for example here, if you look at your calculator, you wouldn't normally measure it in meters, so you have to be careful in how you calculate that. So if I think about my calculator, it's probably what, 20 centimeters by 10 centimeters. I'm guessing it's about that. That means that it's going to be 200 square centimeters. Now, 200 square centimeters isn't on here. That means you're also going to have to do a unit conversion. So a unit conversion, or you could say this is 0.2 meters by 0.1 meters. So that would give me an area of 0.02 square meters, which is A.
What would you, so you would get the same answer if you did a unit conversion?
Yeah, let's do that right now. So I'm going to convert this. There in 1 meter, there are 100 centimeters. But I have to square that. So I have 2 times 10 to the second. That's 200 divided by 100 squared, which is 10 to the fourth. And that is 2 times 10 to the minus 2, which is 0.02. Okay? This other one is, what is a typical person's running speed? Oh, so in this, you had to know what a centimeter is. A centimeter is about the width of your pinky. And then you say, well, my calculator, or my phone is about the same, is about 20 pinkies high and about 10 pinkies across. All right, if you get that, if you don't say it's 20 by 10, you say it's 15 by 30 or whatever, you're just going to pick the closest answer. Because you're never going to get that your calculator is 0.2 square meters. That would be a huge calculator. Or definitely not 2 square meters. That would be like the size of 2 of these, squares on the
We are
floor.
allowed to have a calculator on the test.
Yeah, of course, you can have a calculator, but I do warn you, especially, I know some of y'all are pre-med, MCAT, there's no calculator, so I try to build the exam so that you can use your calculator as little as possible. There are a few that you might need them, but for the most case, you'll need it very little, so I encourage you to try to wean yourself off of the calculator. We do this dimensional analysis. Is that okay? Yeah, I think that this is an area where a lot of students struggle. And you will have a question like this. In fact, you'll have a question like 3 and 4. So let's do both of these, where I'll give you a series of equations, and you have to pick out which ones are dimensionally correct. The first thing you want to do when you look at these is just go through and cancel out things that are in every term. So for example, since I have x here and here, I can get rid of those. Now, you might be able to just look at that and say that it's dimensionally correct or incorrect. Can y'all look at that and tell me? It is incorrect. That's right. Because I know that I have 1 over meters per second squared, the whole thing squared, is equal to 1 over meters per second squared. And those are obviously not the same. Okay? So I'm just going to go ahead and mark that as incorrect. Now, what can I get rid of this in this next one, equation number 2? Right. They're not meters, they're mass in kilograms. I know that it gets a little confusing. I'll try not to do that on your exam. X is meters, right? So I don't think I put mass on your exam just for that reason. People confuse the units and the variable. All right, so now I do each of the 3 terms. By the way, I can also get rid of that 1/2. It doesn't affect the units. V is meters per second. It's squared, so they're both squared. X is meters. A is meters per second squared. So far, I'm okay. Both of these are equivalent. And then I have x squared over time squared. So that's meter squared over second squared. This one is correct. That's right, Harley. Let's look at this next one. Doesn't look like I have... Oh, no, I do have something I can cancel out. Y'all see it? I can't get rid of this x, but I can get rid of...
Oh, the X on the other side.
Yeah, this x. And then I can just disregard the 3 and the 2. Okay, so I have meters, meters per second, seconds. Oh, okay so far. Minus, so the minus is not important. Meters per second, that's V squared. Now the A, this is where you need to be careful. When I have something like that in the denominator, that is a variable that has fractional units in the denominator. I'm going to write that as second squared over meter. When it comes up into the numerator, I flip it. So that cancels out there, and then I lose one of those meters, and so it looks like this one is correct. So 2 and 3 are correct.
Don't you have your limit meters in the Okay, I see. I didn't see the
Oh,
subtraction side of this weekend.
okay,
I
yeah,
thought it was multiplication at first, and it would have meter equals meter squared, but
right,
I see it.
okay. All right? Yeah, this is a, I'll make it into an addition. So that's how you're going to approach those, and you will have that question. It'll just be different equations, but you do the same thing. You'll have one like this too. In order to do this, you first just start with the equation and you solve it for the constant. So here, b is a divided by v. I divided both sides by v. A is meters per second squared. V is meters per second, but I flip it when it comes up into the numerator. These cancel, this cancels with this, and I'm left with 1 over seconds. So those will be your two-dimensional analysis questions, and you will have, I'm pretty sure two, maybe, I think just two. Okay? Students have trouble with that. I think y'all probably okay on 6 figs. You'll have a trig thing. I'm going to give you a triangle, and I'll ask you a side and an angle on that triangle. That's what I did here. It looked a little bit different, but it was the same. I gave you a triangle here, and I asked you, what is this angle right here? Be careful there, because I'm asking for the angle from the plus x-axis. By the way, y'all know what that is? Can you guess what it is? Greater than 180. That's awesome. If you were to...
I don't think it's probably 200.
Right, because if it were 250, it would be over in this part of the quadrant, right? Because 180 plus 45 is 225. So this is our 225 angle, and so it's not 250. So see, sometimes you can just, if you just think about these, you can get rid of all the answers that
What
don't
would be
fit.
the actual way to numerically solve it?
Yeah, so you would, I have the sides of this are 2 and 5, and so I'd start by finding this angle. Theta is the inverse tangent. Let's see, SOHCAHTOA, opposite over adjacent. That's 2 divided by 5, and that's going to be 20 degrees. If I do that in my calculator, in degree mode, make sure you're in degree mode always for this class. If I do that in my calculator, I get 20 degrees. But then, notice there was, oh no, I didn't put 20 as an option. Oh, that's nice. So to get the actual answer, I say 180 plus 20. Actually, 22 might have been that. Does anybody do that? I'll do it. Inverse tan of 0.4. It was, okay, yeah. So that was the 22. Be careful with that. That'll become more important next time, in the next chapter. And to find the length of the line, you would do the square root of 2 squared plus 5 squared. And the square root of 29, square root of 29, it's between 5 and 6, right? Because 5 squared is 25, 6 squared is 36, so it has to be 5.4. Okay, y'all? Do a few more. You will have some kinematics questions. Listen, you're going to have the kinematics and the free response. That'll be worth 2 questions. But then in the exam, in the multiple choice, you'll also have kinematics questions as well. I forget how many, 2 or 3. Let's see how many I had here. 1, 2, 3. Oh, I didn't have free response on this one. Yeah, you'll have 2 or 3 kinematics. That's right. Yeah, it just doesn't give the direction. Let's try this one right here. Motorcycle. Let's see, what do I have? I have V naught, but I don't know what it is. I know that it's not 0. The reason I know it's not 0 is because the motorcycle is moving, and then it accelerates to this new speed of 35 meters per second in a time of 5 seconds. And I also tell you the acceleration, which is 4.0 meters per second squared. So most of these multiple choice, they're going to be single step problems. That is, you have one equation that you need to solve it, has one unknown, and so it's meant to be relatively straightforward. Here, if these are the variables that I know, I'm looking for V naught, I'll use this equation. Recognize that this is my only unknown. So I can say V naught is equal to V minus AT, or 35 minus 5 times 4, or 4 times 5. And that's 15. B is the right answer for that one. All right. Hopefully those are fairly straightforward. If you haven't practiced, they're going to be really hard. But if you practice this a few times, after really just a few times, you'll get the hang of this. All right? Trust me, you will. We worked this problem. If I didn't have a free response on the exam, and you're going to have a slightly more difficult multiple choice question. So this one is a more difficult question. We worked this one in class, but that's because I didn't have a free response on this exam. But you'll have a more difficult free response question, that system of two equations with two unknowns. So most of your multiple choice are going to be more straightforward. If it's getting really complicated in a multiple choice, you're probably not doing it right. All right. Yeah. Yeah. So displacement is, oh gosh, this was like day 1 or so, day 2. It was before the hurricane. So if I'm traveling from A to B to C, so if I'm knowing my distance, that's the total distance traveled, irregardless of displacement or of direction. So I'm going from A to B, that's 4 meters, and then back to C, that is 6 meters. So my distance is 6. But if I'm looking at my displacement, I'm just concerned with where I start and where I end. And in that case, my displacement is minus 2. So my distance is 6. Get rid of these 3. And my displacement is 2 meters in the negative direction. So E is the right answer. We had a little graph like that early on in this chapter. All right? Yeah, Caleb?
I mean, I don't want to jump around, but I just had a question on one of the homework questions.
Yeah, shoot.
The number 7. I did all of it. I was going to mark that. Made a mistake on whenever I went back to check the answer.
Okay. Well, let's take a look. It's important. You'll have questions like this on your exam. I think actually one of your free response, didn't I tell you that? One of your free response is a question like this. I did tell you that. That is true. So here, I want to know the particle's acceleration between 0 and 30. Yeah. The reason you got this wrong, it's just not worded right. It really should say, what is the particle's average acceleration? Okay? And so in doing that, to find the average acceleration between 0 and 30, right? Yeah, the average acceleration is going to be delta V over delta T. But my delta V is 0 minus 0. And my delta T is 30 minus 0. So it's equal to 0. That's really weird, but I don't know why I did it that way. Yeah, and then so you follow me on that? Basically, I'm looking for the slope of this line between those 2 points. On part B, I want to know it between 30 and 40. So I want to know the slope of this line. And the slope of that line, let's see, my rise is minus 40. My run is 10. So the slope of that line is equal to negative 4. For C, I'm looking, what distance does it travel between 0 and 30 seconds? Sort of like what we did before. I want to know the area under this function right here. I can count my squares. Each square looks like 100 meters. I'm counting that right because I have 20 on this side and 5 on this side. Yeah, so each square is 100 meters. So I have 100, 200, 300, 400, 500, 600, 700, 800, combine those two, 900, so basically almost 1,000 meters, so about 1,000 meters. Really about 990 or 80 or so. The more correct way to do that would be to break this into a triangle here, a rectangle here, and another triangle. What's that, Caleb? 1050, okay. Yeah, around 1,000. Okay. But on the exam, you should be able, in a multiple choice, you should be able to get close to that answer and pick out the right answer. And then D is how far away from the starting point. I don't want to talk about that. We're not going to talk about that. What you do is you take that 1050 and then you subtract this because it's below the origin. But I'm not going to ask you to do that on the exam. We didn't talk about that in the class. Okay? You will. No, you won't. Never mind. Not on these. Okay? To wrap up there, is that okay, y'all? Okay, I appreciate y'all coming. It is better, I think, when you devote time. But if you can't come, you can always do it online too.